as the question says, the pulley shown in figure has a radius 10 centimeters and moment of inertia 0.5 kg meter square about its axis. Assuming the inclined planes to be frictionless, calculate the acceleration of 4 kg block. So let us assume that the system is moving like this with an acceleration of a. Now if we assume this block to be block 1 and this to be block 2, then we can say we will be having a component mg sine 45 degrees here in this direction, while there will be a tension T1 over here and T2 over here. Why we have taken this is because this pulley is having some moment of inertia, which means it is not massless, which means the tension on both the sides will be different. And since the acceleration is this towards this side, we will be having the angular acceleration of this pulley as alpha in this direction. So now let us frame the equation for this block 1, for which we can write m1g sine theta, where theta is 45, minus t1 equals to mass into acceleration. Marking it as equation number 1, let us frame another equation for this pulley, for which we can write it as T1 minus T2 equals to I into alpha, which is A by R, upon R, which makes it R square. Marking it as equation number 2, let us frame the third and the last equation for the block 2nd. For this we can write it as, if this is moving down, then this block will be obviously moving up with an acceleration of a. So we can write T2 minus m2g sine theta equals to mass into acceleration a, and mark it as equation number 3. Now if we add the equation first and equation third, then we are going to get m1g sine theta plus T2 minus T1 minus m2g sine theta equals to m1 plus m2 into a. Now putting the value of T2 minus T1 from equation number 2, we get acceleration A to be m1 plus m2 into g sine theta upon m1 plus m2 plus I by R square. Putting the values over here, we get 2 into 10 into 1 by root 2 over 6 plus 50, giving us approximately 0.248, or more approximately we can write it as 0.25 meter per second square.